Hi there, this is a video about composition of functions. Now, if you've ever seen the movie Inception starring Leonardo DiCaprio, now that's rated PG-13. If you're not allowed to watch those kinds of movies, I do not recommend this. However, if you are allowed to watch those kinds of movies, this is a great movie. It's about dreams within dreams, okay? It's an action thriller. Where Leonardo DiCaprio actually goes into people's dreams and then goes, while they're in a dream, goes into other dreams. All right, so it's kind of a weird psychological thriller, but it's dreams within dreams, okay? So when we talk about composition of functions, this is functions within functions. And I like to call these incepted functions, okay? Because of the movie Inception. All right, that's how I think about this. All right, so let's look at an example first. So I'm going to continue to use these two functions f and g for our purposes of talking about the composition of functions. So what we see here, we have a couple different ways of saying this. Let's say that we want to calculate or determine f o g of x, okay? And what this means is that I'm going to rewrite this as f of g of x. All right, in this notation, what it says is that I'm going to take my entire function g and plug it into my function f, all right? So the idea is that I'm going to take whatever g is, 4x minus 5, and plug it into x of my other function, okay? So let's write it like this. Instead of writing f of g of x, what I'm going to do is I'm going to write f of 4x minus 5, okay? And what this means is that if I think of my input of my function, notice how up here, how your input is x, and then what you see in your function is the variable x. What I'm going to do is I'm actually going to take this and I'm going to plug that entire function in for x. I'm going to write 2 parenthesis 4x minus 5 close parenthesis and then plus 7. And what I'm going to see here is that this function here, f of x equals 2x plus 7, and f of 4x minus 5 equals 2 times the quantity 4x minus 5 plus 7. These two things are the same thing. The only difference is that I've changed the input to be what my function g was, okay? And so I'm going to plug that function into f and we'll evaluate, all right? So if I want to continue this, I'd write f of 4x minus 5 is equal to, let's distribute our 2 here. So 2 times 4x gives us 8x. 2 times negative 5 gives us minus 10, and then plus 7. And then what we can do is we can combine like terms and simplify this, and we could say f of 4x minus 5 is equal to 8x minus 3. Okay, and so, because I have put in 4x minus 5, we can also, here's our answer, all right, but we can also come in and say f of g of x is equal to 8x minus 3. All right, so a composite function will give us a new function, okay? Let's look at another example. All right, so using our other functions, what I want to do now is find and calculate g of f of x, okay? And this is notation that we'll see, but we'll also, I prefer to write this as g of f of x, okay? And so what we're going to do now on this example is we're going to take our function f and plug that into our function g, okay? So let's rewrite this as g of 2x plus 7, okay? Because that's our function f, and let's just go ahead and plug that into our x value of our other function. All right, so I'm going to rewrite this as 4 times, and then I'm going to plug in 2x plus 7, and then minus 5. Okay, so once I do this, then we can go ahead and distribute our 4. And so that's going to give us 4 times 2x is 8x. 4 times 7 is plus 28, and then minus 5. All right, so g of 2x plus 7 is equal to that. And then you've got g of 2x plus 7. It would be equal to 8x plus 23. All right, and so that's our answer. Okay, that's our composite function. And so from here, what we want to do is we could really write this as g of f of x, all right, is equal to 8x plus 23. Okay, so again, all I'm doing from one of these problems to the next is I'm merely just putting one function into the variable of the other function and then evaluating this, okay? And that's the idea. All right, so let's look at a couple of other examples. Okay, in our next example, we're going to use the same functions, okay, of f of x and g of x. And what I want to do is calculate f o g of 2. Okay, and when I see this notation, all right, I want to translate that and write it in a different way. I want to write it as f of g of 2. Okay, and so we can do this two ways. All right, I'm going to do the first method, which is kind of follows what we have just done before. All right, what I want to do first is find f of g of x, which we've already done, okay? And that's when we took our function g and plugged it into x of our other equation, all right? And so as a result, that's going to give us 2 times 4x minus 5 and then plus 7, all right? So if we evaluate that and write f of g of x, then that's going to give us, what was that, 8x minus 10, and then plus 7, so f of g of x is equal to 8x and then minus 3, okay? And what we can do is now what we want to do is plug in 2 into our x value and get a y value as a result. All right, so if I calculate f of g of 2, okay, then I'm going to plug in 2 in for x. So I'm going to get 8 times 2 and then minus 3. And so from here, what we would want to do is we'd want to do the math. 8 times 2 gives us 16 and then minus 3. So f of g of 2 is equal to 16 minus 3, which then gives us a value of 13. All right, so f of g of 2 is equal to 13. All right, so in using that composite function, when I plug in that x value, we get the y value. So that's the first method, all right, that we'd want to do, where you can actually determine your composite function and then go from there. All right, let's look at another method. All right, so on method 2, what I would want to do is I can just simply evaluate g of 2. All right, so if I want to just look at the value of g of 2, all right, let's do that. So g of 2, and all I'm going to do is plug in 2 into my x value up here and generate my y value. So I'm going to do 4 times 2 and then minus 5. All right, and 4 times 2 is going to give us 8. Minus 5 gives us 3. All right, so what we know is that g of 2 is equal to 3. All right, and remember what that means. That means that x was equal to 2 and y is equal to 3. Now, because g of 2 is equal to the number 3, what I'm really doing is I'm now taking that value of 3, my y value, and that's going to be my new x value of my function f. So really what we're finding here is once I figure out what this is, g of 2 is 3, then I can plug in 3 into my function f, okay? And then I can evaluate that. Now check out what we're going to get here. All right, so if I do f of 3, again, I'm just plugging 3 into my function up here. Then we're going to get 2 times 3 and then plus 7. All right, so then we've got that f of 3 is equal to 6 plus 7, which gives us 13. All right, So f of 3 here is going to be 13. All right, and that's what we ended up getting here, okay? And that is our composite function, all right? So, I could then write f of g of 2 still is equal to 13, all right? And that's the answer. That's what we ultimately want to find. Whether you want to create your composite function or plug in, you have an inside function, g of 2, figure out what that is, plug in that y value into your function f, and evaluate. And that's the idea. That's all I've got for this video. Hope you enjoyed it, and we'll see you soon. Thanks. Bye.